I don't know if you can see me. Can you see me?
Yes, ma'am.
Yes, ma'am.
Cool, cool. All right, guys. As you know, you're coming back to school on Monday. And I think, especially my class, I would like you to, if you have your textbook at home, bring it to school. We're going to, when we go back to school, we're going to start exponents. Now, if you've been following these Zoom lessons during the lockdown, I actually did cover exponents. I went through the rules, the simplification, and then we'd go on to the surds and the rational fractional exponents, rationalizing denominator, and exponential equations. So that's what we're going to be doing for the first week. So I'd like you guys to bring your textbooks so that we can work through some of these examples, please. Okay, so that's my class. All right, I think as far as I understand, yeah, the boys are coming back. Sorry, not the girls. The boys are coming back for the first week. And the girls, there will be a function sort of, what do you call, investigation that you will do during the course of the week. And then we swap, something like that. Okay, I'll know more by Monday. Everything keeps changing at the last minute because the government keeps changing what's happening as well. All right, so I thought today, let's just revise a bit of trig. I have not seen your cycle yet. I've just been told, and you'll be writing really at the end of July. So you still got a good 3 weeks, but you know, 3 weeks go very fast. So the cycle test can be on all the trig that we taught you, and I thought I'd revise some. And apparently they'll put nature of roots. And what else did he say? Nature of roots, trig. I can't actually remember the other. I think it is exponents, actually, the section we're going to be doing at school. So those sections, I think, are in the cycle test. But I haven't seen it yet. I've got these questions from one of my extra math students who goes to Kingsmead, and they're actually very nice questions. So I thought we'll do them. But what I'm going to do is let you try them first. So question 1. Write it down if you would like to. If 4 times tan of alpha equals to 3, and alpha is an element from 180 degrees to 360 degrees. Square bracket. Okay. Determine the value of colon and then 4 cos of A without using a calculator and use a sketch. Now, when you see those 2 instructions, without a calculator, use a sketch, you've hit your Pythagoras. So I'm going to give you, this would be worth 3 marks. Okay, I'm going to give you 3 minutes, starting from now, to see if you remember how to do this. And then I will do it. 3 minutes, starting now. If you've just joined and wondering why it's so quiet, I'm giving everybody 2.5 minutes to do this question. We're just revising a bit of trigonometry. Okay, how's it going, guys? You nearly finished?
Yes, ma'am.
Okay, let me show you. All right, so look here. You always want to isolate the trig function, which is tan of alpha in this example. So the 3 is already on the right, but this 4 is joined to the function tan a by a times. So to get rid of it, remember you do the opposite operation, which is division. So if you divide both sides by 4, then you're just going to get tan alpha equals to 3 over 4. Now this is a ratio. Notice it is a positive ratio for tan. So using a little cast diagram, all students take care, you would say, in which 2 quadrants is the ratio for tan of an angle? In which 2 quadrants would it be positive? And hopefully you'd say, well, quadrant 1, where all 3 ratios are positive, and quadrant 3 is where tan's ratio is positive. But now you need a restriction, otherwise you're going to have to draw 2 diagrams. And the restriction is right here. If you look carefully, alpha is an element from 180 to 360. So that is 180 to 360. So in other words, dish, dish. So therefore, we are in quadrant 3. All right? Without any doubt, when they say use a sketch, you're in quadrant 3. Now, normally, we give a mark for being in the correct quadrant. That's why these questions are normally 4 or 5. But I noticed the IEP schools are very stingy with marks. Just for interest, when you label your angle alpha, it's actually all the way there. It is a reflex angle. Okay, that's the y-axis, that's the x. Remember, always come perpendicular to your x-axis. So when we do put this, can you see that this is where x is negative? Because I'm on the left. Y will be negative because I'm going down. And remember, your hypotenuse is always positive, or the radius. So therefore, they said, or we've worked out, the tan of alpha is 3 over 4. Now you should know that tan is the y over the x. The y over the x. Now what makes this interesting is, if you think about it, this has to be minus 3 and this has to be minus 4. Because the minus over the minus will give us the positive ratio. But you have to realize that it's actually minus because you're going to the left of the origin and down. Using Pythagoras, you can then this, which will be 5, because that's one of these triplet triangles. Okay, having done that, so normally 1 mark for being in the correct quadrant, 1 mark for the getting your missing side. Then you end with, so what is 2 times sine alpha? Now remember, sine alpha is just going to be a ratio minus 4 times cos alpha. And remember, cos alpha is just going to be a ratio. So the answer is going to be 2 times. So the ratio for sine, remember we know that is the y over the, yeah?
Can you please change your marker? It's getting a little bit hard to see.
Oh, sure. I've actually got refills for all these pens, so I think they all might be running out. Oh, that's better. Okay, so it's 2 times. So think in your head, what is the ratio for sine of A? Do you all agree it's going to be minus 3 over 5? That is the ratio y over r. And then minus 4 times the ratio for cos of A, you should all remember, is the x over the r. So that ratio is going to be minus 4 over 5. Okay, then if you multiply this, you're going to end up minus 6 over 5. That minus times minus becomes positive. That 4 is over 1, so it's 4 times 4 is 16, and 1 times 5 is 5. So because they have the same denominator, you can just say, what is 16 minus 6? And you get 10. 10 over what? Over 5. So your final answer is actually just going to become 2. Okay? So that was a nice question. So definitely 1 for the final answer. You see, theoretically, 1 for the correct quadrant, 1 for Pythagoras. And I'm telling you, if this was a green side example, there'd be 1 there, 1 there. So I don't know how the IEPs possibly got that to be out of 3. That would be 5. All right? Anyway, having said that, let's move on to the next question. So if you have to screenshot that or copy it down, I hope I've given you enough time. So I can now proceed to the next one. All right, question 2. Again, I'm going to put it on the board. Yes, Landra? Did someone say something?
No, ma'am.
Okay, as far as question 2, I'm going to put it on the board and then again get you a bit of time to try it. So question 2A. Sine 180 degrees minus x over cos of 90 degrees plus x plus sine of 360 degrees minus x. Okay, now they've made this for 4 marks. I can only tell you when I've done it if that is a true statement. So I'll give you a few minutes to start it, and let's see if you remember how to do these questions. This is reduction with that compound angle. You've got to first look at the angle, see which quadrant you're in. Then you say to yourself, right, if I'm in whatever quadrant, is my trig function positive or negative? And then you reduce to the acute angle. Okay, so 2 minutes, go for it.
Ma'am,
Yes, darling?
how do you find the value for x?
Okay, we're not solving for x. Okay, so nowhere here does it say solve for x. That x is representing any acute angle. In your head, you can pretend it's like, for example, 10 degrees. So you see, what you do, 180 degrees is a positive angle. So with positive angles, flying pens, the terminal arm, aka the radius, will always go through the Cartesian plane anti-clockwise. Now, 180 would put my terminal arm there, right? So I would at this point be there, but it says minus a little bit. Now, with negative angles in trigonometry, we go the reverse direction, which is actually clockwise. So the terminal arm went 180 minus, let's pretend, 10 degrees. Then I would know the terminal arm is therefore in quadrant 2, right? So now that I know I'm in quadrant 2, you would say to yourself, right, is the ratio for sine positive or negative in quadrant 2? Which brings in your all students take care. Aha. So sine's ratio is positive, so it's positive sine. And remember, if you get a 180 or a 360, you keep the name and you do reduction to the acute angle. Tanaka, did you follow what I did with the trig, or were you not really watching the trig?
No, I found out that you did the trick when you did it.
Okay, so yeah, we'll have to just spend a bit more time working with the trig, Tanaka. Don't worry about it for now. All right, this angle is 90 plus a little bit more. So let's remove the terminal arm. Okay, that is 90 degrees there, plus a little bit more. So again, 90 plus a little bit more will put us in quadrant 2. Now, the first thing, if you see a bracket with a 90 in it, you must know we're going to co-function. What does that mean? We will go sine of 90 minus the angle, which changes this, okay? So in other words, just look here. The angle puts me in quadrant 2. You always look at the original name to get your plus or minus. So you find out first the compound angle puts us where? Quadrant 2. Then you say, okay, but wait a minute, cos is negative. Only sine's ratio is positive in quadrant 2. But because of the 90, hopefully you guys will remember, we will change cos to sine of the angle. Okay, it's just something that we have taught, and if you missed out the section of trig, then obviously you won't quite understand this. We'll have to make a plan for those who don't know what's going on. Okay, 360 minus x. Let's first work out which quadrant our terminal arm is sitting in. So we start there, we go full 360, so we're now back on the positive x-axis. And then we've got a reverse direction minus an acute amount, which would make my terminal arm in quadrant 4. Now in quadrant 4, do we all agree that sine's ratio is negative? Because only C for cos's ratio is positive in quadrant 4. So it's going to be positive. Now, sorry, sine is negative, and now remember, once you've got your plus or minus, if it's 360 or 180, you keep the original name. So it reduces to negative sine of that acute angle. So that is 3 marks out of their so-called 4 marks. Let's see where we're going with this. Now, please, guys, do not cancel across plus or minus signs. Let's first collect my like terms, because if you think about it, you agree I have minus sine x. A plus times a minus is negative. So I have another minus sine x. So minus 1 sine x minus another gives me minus 2 sine x's. Now there's a ghost 1 in the numerator. You don't see him. I always draw my ghosts. And therefore, that is 1 times sine x. That is minus 2 times sine x. So the sine x's can cancel out. And remember, cancel them in a pencil. And your final answer, you'll be left with negative 1 over 2. Right. Now, you see, to me, I think what they've done, there's the 4 marks. I think that one was correct. 4 marks for that question. Okay, so this type of question, as I say, I haven't seen the cycle, but I can guarantee you it will be in there. I'd be flabbergasted if it's not, because there should be a bit of everything in that test. All right, so let's move on with the Kingsmead trig cycle test. Question number. Question 2, but it's question 2b, which means if you can deduce, the previous question would have been question 2a. Okay, so I'm not going to photograph this. It's going to come out too fuzzy. It's already fuzzy for me to read, because this already she photographed and I printed out, and it's very smudgy. Okay, so we've got cos of 115 degrees times cos of 214 degrees divided by cos of minus 65 degrees times sine of 236 degrees. Okay, and this question is also, according to them, 4. I would disagree and say it's at least 5. Okay, so I just want to make sure I copied it down right while you copying it down. And remember, what is your aim? Your aim, wherever you get a big angle, in other words, if it's bigger than an acute angle, if it's obtuse or reflex, you have to do reduction. You've got to get it into an acute angle. But before you do the reduction, and this is where most of you go wrong, you've got to look at the angle and see which quadrant that angle puts you in. Because once you know what quadrant the angle puts you in, you've got to look at your, when I say sine, I'm talking that sign. Are you going to be positive or negative? Is the ratio for that particular trig function going to be positive or negative? All right, so remember, all students take care. This is quadrant 1, 2, 3, and quadrant 4. All right. So now, and just for interest, that's 0 degrees, up there's 90, that's 180 degrees, 270, back to 360. Okay, so cos of 115, that would be 90, so it has to be in quadrant 2. right? I think you could work that out. Somewhere in quadrant 2. That would be 115 degrees. Now, because we're in quadrant 2, you look at cos and say, would the ratio be positive or negative? Oh, sine's ratio will be positive. So cos's ratio will be negative. So it is negative cos. Now, all you need to do is in quadrant 2, so I'm looking for my calculator. It's still in my school bag from being at Greenside this morning. You just go 180 minus 115 and you write down your answer. You don't need to show any other steps. But I warn you, grade 11s, if you forgot to go minus, you will lose that mark. So before you do reduction, remember to work out which quadrant does the angle put you in, and then you can do reduction, okay? And then get your sign. Okay, so 214, let's take this away. Can you work out for me which quadrant that angle? That's a reflex angle. Do you agree? It's positive. So we go anti-clockwise, and we're going to go past 180. But 214 would come before, obviously, 270. So we're definitely quadrant 3. Okay, then you say, would the ratio for cos in quadrant 3, would it be positive or negative? Now, only t for tan theta's ratio is positive in quadrant 3. So cos, therefore, is negative. So it's negative cos. When you do reduction, always keep the original name. Okay? Sometimes we have to, in the second step, co-function, but I never recommend do reduction and co-function at the same time. Now, to get the acute angle, do not touch 270, right? All you do in quadrant 3, just type in that big reflex and minus 180, and the acute angle will be 34 degrees. Now, let me explain to you why I did that. I want to do its horizontal reduction. In other words, you want the acute angle, but the horizontal one, sandwiched between the terminal arm and your x-axis, not the y-axis. So 214 degrees, can you see that's 214? So if I take the 214 and I minus on the calculator the 180, I'm left with the horizontal acute angle. Now, if you had taken the 270 and then subtracted the 114, or 214, sorry, you see you left with the wrong acute angle. You left with the vertical acute angle, which is not the one we're looking for. So when we do reduction, we always say it's horizontal. Okay, having done that, we have 2 marks. Now, what do you do with negative angles? Well, you could either just work it out by drawing it, or there's a rule that says just add 360. I think for trying to make this as easy as possible, let's just keep to that rule. So just take your minus 65, add 360. That is a rule to make negative angles positive, and then you're going to get 200. Now you won't, it's not an acute angle, but you will get the mark when you do the reduction in the next step. Let's look at our last angle here. Okay, so we got sine of the angle 236. Do you all agree 236 will also put me in quadrant 3, and the ratio for sine is negative. So it is negative sine, and remember to get the horizontal acute, just take that big reflex minus the 180, don't write it down, just do it, and you get 56 degrees. Okay, this is looking interesting. Okay, let's just make sure I did that right. 236 minus 180, yeah. Okay, let's do the reduction here. So I know at this point you're not sure what to do, just leave it. Okay, so let's just not touch in trig when you don't quite know where you're going, getting funny angles, and you definitely on no calculator. Okay, then what I suggest strongly is just do everything you can and see if you can see then where you're going. Okay, 295. Now watch that one carefully, right? 295 is in quadrant 4. Yeah, and in quadrant 4, cos is positive. So it's positive cos, and to get the horizontal acute angle, which is that one, you would just go 360 minus that angle. So if I go 360 minus 295, I get 65 degrees. Okay, let's see if that helped in any way. Okay, the first thing I notice is that I can cancel something. Even though this is negative, I can cancel the cos 65 with the cos 65. But remember, there's still a -1. You cannot forget about that. So let's neaten it up and then see if we know where we're going next. By the way, that's 4 marks. I already said this is going to be more than 5. Okay, so in the numerator, I have minus times minus, which is positive, and I'm left with the factor cos 34 degrees. And in the numerator, I have a negative, and I've got sine of 56. Now, when you get cos of an acute angle and you get sine of an acute angle, and the acute angles are not the same, add them up and see if you get 90 degrees. So if you take your 56 and add your 34, jackpot, I get 90, which means this is a classic example where you have to co-function. Right, now you can choose, do you want to co-function the top or the bottom? Your decision. I'm going to co-function the top. Okay, so cos of 34, I can change that to sine of 90 minus 34. And that would be 56 degrees. So that is a mark. And downstairs you have minus sine of 56 degrees. So your final answer, that would cancel, leaving you a -1. So you see, I would have made that 1, 2, 3, 4, 5, 6 marks. I don't know how the IEPs do it. I really don't. Poor chickens. Tell me something, how long have we got? My watch battery died just before the lesson.
We have got 11 minutes, ma'am.
Cool, I love 11. Okay, so let me turn the page. Dum, 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 dum. Okay, not that page, this page. Okay, carry on with trig. Right, I'm going to erase the board. Oh, we're now on question 3. Now, I know that my class, we've done this. Am I right? Did we do trig? Yeah, we got through trig. I didn't do much identities and then the whole lockdown. But then I did identities on the Zoom lessons. But anyway, it's not an identity. Question 3, if you've either seen it or you haven't seen it, let's write it down. If cos of 50 degrees equals to k, express the following in terms of k. And A is going to be sine of 50 degrees. That will be, I'm going to go with 3. And B is going to be tan of minus 220 degrees. And they've written 3 marks. I don't know if it's worth 3 marks. Let's see. Okay, so angels, copy that down. And then I'll just do it. I think we're running out of time for you to try and then me to do it. Okay, when you get the sine of an angle, cos of an angle, or tan of an angle equals a variable, and they want you to determine in terms of that variable, you always draw what they give you. Draw what they give you. That is just over a 1. Now, a lot of students say, which quadrant, ma'am? I say, well, isn't 50 degrees acute? So surely 50 degrees, we'd always be drawing these in quadrant 1. Right, so that is 50 degrees, that's 90. Now, cos is the x over the r, okay? The x over the r. So in other words, this is k, and this is 1, the ghost 1. Then using Pythagoras, you need to find this side. Now, I'm just going to go into it. You're going to get 1 minus k squared. Do it. You can that is k. You just have to subtract from the 1 and then root it, but obviously you can't do that. So it must stay in its square root radical. Okay, so now that we've done that, sine of 50 degrees, we've got the same angle, so sine is the y over the r. So it's going to be square root of k squared over the 1. Now, if it's over the 1, you don't actually need to show that 1. So that would be your answer for 3 marks. Let's try and work out 3 marks. Do you know what? I think that would be 2 marks. All right. What I like about these type of questions is they can bring all your reduction into it. So before we can go here, we've got to make this negative angle positive. So what's the rule? Just take your negative angle and add 360 degrees. So tan of minus 220 is the same as tan of positive 140 degrees. Okay, now we can do reduction. 140 degrees, do you all agree, puts you in quadrant 2. Okay, and in quadrant 2, tan is negative. So that reduces to negative tan. Then we're going to go 180 minus 140, and we're going to get 40 degrees. Now I can see where this is going. This is going to be fun. Because the only way we could get that to 50 degrees is by using the cofunction, but they took out the cofunction of tan in 2008 out of the syllabus. But there is still a way you can do your cofunction with tan, because if you remember, okay, so there is, the fact it's negative, that's from my reduction. But we can write tan of any angle as sine of that angle over cos of that angle. So now just keep the plus or minus. If you cofunction sine of 40, do you agree that you'll get cos of 50? And if you cofunction cos of 40, you will get sine of 50. And then that just means you have minus, what have we learned? Cos 50 over sine 50 is 1 over tan 50. Oh, clever. That must be a mark. So now the next question, in fact, that must be a mark. Yeah, I don't agree with this whole mark thing. The final answer, okay, we got a negative. And 1, the minus 1 divided by tan, which is the y over the x. And then you know you go into a tip and times. And our answer is going to be negative k over the square root 1 minus k squared. Now, you do not have to rationalize your answer. That is way enough work for 4 marks, okay? You would only rationalize if they said, write your answer with a rationalize your answer, but they don't tend to do that in trigonometry because there's not enough time and there's not enough marks. So that was actually quite a tricky one. A lot of you might have done the reduction, but then had no clue what to do. You could see and the 50 add up to 90, but you would not have known that the cofunction, you see, I knew it was cot theta, which is 1 over tan of that theta. But they took that out the syllabus at the end of 2007. You just had to do it like I did it. Would I imagine we got about 3 minutes?
3.5 minutes, ma'am.
In the last, teach another question. Obviously, the only thing I really didn't I want to just remind you on Monday, please, because it's really cold in the open, please, you know, we really social distancing. Don't mess around. Don't go high five your friend, or you know, just the minute a teacher's not looking, go right up to a student and take your mask off. I've seen some horrible things going on with these kids at break because they've taken their masks off to eat, but they're standing. They might happen. Grade 11s are very vigilant on this. If anyone doesn't know what's going on after Monday, you can always SMS on this group because I You've all got your emails. As far as back for a week, we're doing exponents, and the girls have their function investigation, and then we swap, and then the girls will do the exponents and the boys will do the function investigation. Okay.
Now,
anyway, I love you all. Yes, Lam.
can I take that this is the last Zoom lesson that we will be having?
Never say that. Never say never. Because what if the schools close down again in 3.5 weeks' time? We'll be Zooming the whole year. So don't.
But temporarily, we're stopping the
And
Zoom.
the other thing is, guys, let's say we're running out of time at the end of the year, and the weekends give you Zoom lessons so that we get through the syllabus. So never say never. I've already had 2 Saturdays for the grade 12s, just a lot absent. So like for the last week, I've had 9 students absent. So I've done them 2 Saturdays just to try and catch those kids up. So never say never, never. Bye.